welcome to another Dive in 5. Today we're going to be talking about first grade compare and order numbers to 100. So here's your first task. What I want you to do is pause the video and complete the task in the blue rectangle on your own or with a team or partner. This problem you can probably solve pretty easily, but I want you to act as a first grade student trying to solve this problem. What models and vocabulary would or should a first grader use to answer this task? When you're done recording different models and strategies for how this task could be solved, sort them into 3 groups: concrete, representational, and abstract thinking. Now let's take a look at the progression of comparing and ordering numbers with the best benchmarks. You can see the background knowledge that students should be coming into first grade with from kindergarten, using up to 20 objects and vocabulary to compare values. In first grade, they begin plotting and ordering numbers as well as using symbols to compare up to 100. Take a look at what we are setting them up for future grades. Notice anything? Of course, you can see that they're going to continue to plot, order, and compare numbers, but with greater values with each grade level. Remember when you sorted the different ways you solved your task into concrete, representational, and abstract? What did your concrete representation look like? Here we have some bundles of sticks or straws of 42 and 24. Here, when students make this model, they can easily see that the values are not the same. They are different. Then they can label their models with how many 10s and 1s, and then make the connection to the expanded form to further prove that 42 and 24 are different. Have conversations with students about which is greater and why it's greater. It's greater because there are 40 or 4 10s and the other number has 20 or 2 10s. So 42 is definitely greater than 24. Listen for students' vocabulary as they're making their explanations. Also have students use place value charts and base 10 blocks as a concrete model, or even building with color counters. So once students have a good grasp on their concrete models to compare numbers, then you can start using some representational thinking. So here's a hundreds chart. We can use the hundreds chart to compare 23 and 32. Although the digits are the same, we can say, oh, well, 23 is closer to 0 and 32 is closer to 100. This may still be a little bit abstract, so what we can do is use the hundreds chart to build a number line. Each strip we place next to each other to show that it is also a number line. Now, I know what you might be thinking. The number line is an abstract model, right? Well, this is a representational model that connects to the abstract way of thinking. The number line represents the magnitude of the numerals on the number line. You can see that the magnitude of the numbers are being represented because 32 is farther from 0 and 23 is closer to 0. So I know it is a lesser number. When representing numbers on a number line, students should understand that the number on the right is always greater. Now, students may need support with different types of number lines and their understanding of numbers. So they may first need a number line that has all the numbers there, or you may be able to move to an open number line like this one. Here we can jot down the 10s, 10, 20, 30, 40, and talk about, well, where would 20 be and where would 30 be? 30 to 23 and 32. Once we jot them down, then we can start have those sentence stems of 23 is less than 32 because it's on the left and closer to 0. We can also create another sentence stem that 32 is greater than 23 because it's on the right and farther from 0. Other representational models are, again, those open number lines. Now, if students have trouble with this, you may ask questions like, is your number more or less than 40? And they may need to represent these numbers with that expanded form model. 40 plus 2 more. So it's going to be a little bit past that 40 line on the number line. Another great strategy for you to use as the teacher is to open up. Have a great big open number line on your board or on chart paper in the hallway and put a couple numbers out there and have the discussions about where would this number go on the number line. So maybe they would start with that greatest number. Well, I know that 99 is super close to 100, so let's stick that sticky note right there. Then let's do 76. 76 is a little bit closer to 80. Now we have 65 and 68. Which one is greater and how do we know? Or where do we place it on the number line? So how close is this number to 60 or to 70? Well, I know that 68 is closer to 70 because it's only 2 away. So we can move those numbers right to where they go on the number line. And then from here, think about how we can make connections to having them order numbers. So which number is the greatest? Well, the number that's closest to 100, not closest to 0. The number that's all the way to the right is the greatest. Which number is the least? The number that's all the way to the left or closer to 0. Now, could a student use their number line to now order these numbers from greatest to least? Absolutely, which is why this is a great representational strategy for students. So like I just stated, once students can do that representational thinking of ordering numbers from least to greatest on a number line, then they can move to abstract, where they can use the place value of digits and think about where those numbers are on the number line so that they can simply write them in order from least to greatest or greatest to least. Now, another abstract way of thinking is when they immediately begin to use those symbols, the less than, greater than, and equal to symbols. And then finally, when you're giving them numbers, they can just explain, well, I know 59 is less than 79 because 79 has more tens, so it's a greater number. Now let's take a look at the misconceptions. One misconception is that students may compare numbers based on the value of each single digit and not understanding the place value. Take a look at this. A student could say 58 is greater than 23 because 5 and 8 are greater than 2 or 3. To support this, we can provide more experiences for students to compare physical and concrete models, emphasizing the value of each place. Another misconception that students have in all grade levels when we're comparing numbers is that they confuse the terms and symbols for greater than and less than, or they don't know how to read them. A lot of the times, and I've made this mistake myself, is that we teach the strategy of the alligator or the monster. It eats the bigger number, draw the teeth on the symbol. But we really want to avoid using alligators, monsters, or other tricks to learn about comparison symbols. Instead, we want to think about the mathematical ideas connected to numbers and the associated sentence stems. So let's take a look. 26 is greater than 15. Once students can read that sentence stem, then they can make the connections to the symbol by drawing dots. 2 dots next to 26 because 26 is greater, and 1 dot next to 15 because it's less. Once they connect the dots, they will have the correct symbol. Once students write these dots, also have them read it as a sentence. 15 is less than, because there's 1 dot first, 26. They can also use this strategy to prove that something also is equal. And look at the number line. The symbol is also connected to the number line. Notice that the greater than and less than signs show students that numbers are getting larger to the right and lesser to the left. One more model to show what we were just talking about. We want students to possibly go back to that concrete if they need to build the models for each of the numbers, then say, okay, well, which one is greater or less? They can easily see that 42 is greater than 24. So I can say 42 is greater than, so I draw my 2 dots and my 1 dot, then I make the connection, and now I have the symbol and I can read it as a sentence. Now here are our concrete, representational, and abstract thinking islands. The bridges in between are important because you can always go back and forth, and we use the bridges to make connections among the different strategies, thinkings. But keep in mind, you want to start with the concrete here, really build that foundational understanding with those models, and then move to representational and abstract thinking. But back to the concrete if they need that. All right, that's all for today's Dive in 5. We'll see you on the next one.